Quadratics Section 1 deals with factoring. Factoring is one of the most important skills that we cover in Algebra 2, as it is used in many different processes and many different types of problem throughout the rest of the class. So this is an extremely important topic to make sure we understand. So this video, we are just going to simply cover some of the basic introductory material, such as some vocabulary that you've hopefully heard before. A monomial, when we talk about different polynomials, so we have the different prefixes. In this case, mono means single, so this is an expression that is either a number, a variable, or the product of a number and one or more variables, but it is just a single term. Mono, again, means just one. So 4 would be an example of a monomial. X, or any variable, is an example of a monomial. Here we have x times y, which is the product of two variables. Or we could have something like this, negative 9xy to the 7th would be one monomial. All of those are being multiplied together. A binomial is where you have the sum of two of these monomials. We've seen these quite a bit. One example, very basic, would be just x plus 3. Another example would be 2x minus y. Notice this has a minus sign. Really, subtraction is just addition. It's just adding a negative. We just show it with a single subtraction symbol. Or something a little bit more complicated, like x squared minus 4y to the 4th. That is still a binomial. There are only two terms in that expression. Next, we have the trinomial. This is the sum of three monomials. Again, the prefix tri means three of them. So an example, x squared minus 4x plus 3. Or another involving a couple of different types of variables, x squared plus 2xy plus y squared. Again, each are a trinomial because they have three terms. And this idea of factoring, finally here. Factoring is undoing multiplication to write the expression as the product of two or more factors. So when we factor, since it is undoing multiplication to check our factoring, we could always multiply our expressions, or our factors rather, back together to see if we end up with the original expression. The first part of factoring is looking for what's called a greatest common factor, or GCF. This is the largest integer, meaning it could be positive or negative, that can be divided into each term. And it also will at times include variables. So I'm going to talk through a couple of different ways that you could go about finding the GCF. First way is if we have the two values 45 and 9. The first way you could do this would be going back and using what's called a factor tree. So if I have the number 45 and I want to break this down into some factors, a lot of times the first factors of 45 that people have come to mind would be 5 and 9. If you multiply those back together, you get your 45. But what we are looking for are called prime numbers. Prime numbers are numbers that can only be divided or only have factors of 1 and themselves. So like 5 is an example of a prime number because it is only divisible by 1 and 5. 9, on the other hand, is not a prime number. It can be broken down further. 9 has factors of 1 and 9, but can also be broken down into 3 and 3. So that tells us that it's not prime. When we continue to break this down then, because it's not prime, we would break 9 down into 3 and 3. And now each of these numbers, each of these factors are what are called prime factors. We do the same thing with the second value, 9. This one is just 3 times 3. 3 and 3 are both prime numbers. So here we can see that we have each of these completely broken down into their prime factors. I'm going to erase this just to make this a little less confusing, hopefully. Now, when we look for the greatest common factor, we look for what prime factors do each of these two original numbers have in common. So looking into, or looking at the basically bottom with the way I have drawn it, the bottom of the factor tree, I'm looking for what is the same. Well, in each of these, they have two factors of 3, which means those two numbers I would take and multiply together to get the GCF for those two numbers to be 9. So again, that's one option on how you could show this. Another option that I show is if we take, and we're going to do the same thing, but it's just a little bit different visually. If we take 45, some people prefer this because it maybe takes up a little bit less space. It's maybe more systematic. I don't know. It's kind of just a personal preference. But some people will look at this and they'll start with the lowest prime number. The lowest prime number is actually 2. So we would ask ourselves, is 45 divisible by 2? Do we get a nice whole number or integer number if we were to divide by 2? And the answer is no. So 2 is not a factor of this. So we move on to the next prime number. The next prime number is 3. And 45 is divisible by 3. If you divide 45 by 3, you're left with 15. 15 also has another 3 as a factor. 15 divided by 3 leaves you with 5. And there would be the same 3 prime numbers as you saw up above in that factor tree. If we went to the 9 that we were given, 9 is not divisible by 2, so we move on to 3, the next prime number. 9 is divisible by 3, and when we divide by 3, we end up with 3 again. So here we can see our lists of prime factors, again, just written a little differently, and then we would be able to see then that what do they have in common? They have each 2 3s in them. So again, that GCF, when we multiply those values together, would be 9. So really kind of up to the individual how they want to show the work or the prime factorization for each individual term. If we move over to part B and we want to take the term 3x, this is a monomial even though it now is a number, coefficient, and a variable, and we want to do prime factors with this, we would be able to go through the same process. 3 is a prime number itself, and then the next factor that it has is actually that variable x. So we would add that or include that in our list of factors. The 4x, 4 is 2 times 2 when you have prime factors, and then the x is also another factor as well. So in this case, what do these two lists of prime factors have in common? They just have the x in common. So in this case, the GCF of those two monomials is just that variable x. Lastly, we look at 12x squared and 18x. So 12x squared, if we break this down into prime factors, again, if you prefer to make factor trees, you certainly can. I like the method of kind of just thinking through it myself. 12x squared, focusing on the coefficient first. 12 is divisible by 2. Again, that's the first prime number that we need to start with. If I take 12 and divide it by 2, I get 6. And I know 6 is also divisible by 2, so I have another 2 as a factor. 6 divided by that 2 is 3. So again, I can check this by taking 2 times 2 and get 4, and then 4 times 3 to get 12, and I'm back at that original coefficient from my monomial. Then the x squared, we have to remember, is really 2 x's multiplied together, so we would list 2 x's in our list of factors. Then if we move on to the 18x term, 18, again, divisible by 2. If I divide 18 by 2, I get 9. And I know that 9 is 3 times 3. And the more practice you get with this, the quicker this will become, whether you're doing this method that I'm showing right now or using a factor tree. And then again, can't forget to include the x. So now looking at these lists of prime factors, what is the GCF for these two terms? The GCF here would be they each have a 2 in common, they each have 1, 3 in common, and they each have an x in common. So if we take those and multiply them together, 2 times 3 times x, our GCF is 6x. At this point, we're going to leave this and we're going to come back and talk about the factoring process next class.